We're back. Okay. Time for some questions. The circulatory system is comprised of which three primary components, excluding the heart and lymph system? So we have A, which is arteries, veins, and capillaries. B, blood, cardio, and vascular. C, plasma, interstitial fluid, and blood. And D, endocrine system, immune system, and thermoregulation. The answer is B, blood, the heart, and the blood vessels. Blood, cardio, heart, and vascular, blood vessels. Why? Because the structure it's self-explanatory. Question 2. If an animal experiences cessation of heartbeat, approximately how long is the golden window before irreversible damage occurs? A, 1 minute, B, 10 minutes, C, 4 minutes, D, 30 seconds. The answer, I believe, is C. Excuse me, 4 minutes. All right, question 3. Which assessment technique listed below is primarily used to evaluate heart sounds and murmurs? A, echocardiography, B, electrocardiography, ECG, C, heart rate rhythm assessment, heart rate/rhythm assessment, D, auscultation, which is part of heart assessment. I believe the answer is A. No, the answer is C, heart rate/rhythm assessment. Then that's because the sounds and murmurs are assessed as part of the heart assessments. Oh, it's because diagnostic assessments of CV function include heart assessments such as heart rate, rhythms, sounds, and murmurs. Echocardiography and ECG are separate imaging or electrical assessments. Hey, Aiden. How you doing? Okay, part 2, fluid balance and body fluid compartments. Question 4. What is the primary solvent component necessary for maintaining fluid homeostasis in the mammalian body? A, glucose, B, salts, C, water, and D, proteins. I believe the answer is B, salts. No, the answer is C, water. I mean, that makes sense, but salts are important too. Here's why. A key portion of homeostasis is the maintenance of a relatively constant fluid volume, and the components include the solvent water and its solutes. So yeah, salts and water. I feel like that was kind of a bad question. Question 5. According to the 60-40-20 rule for body fluid compartments, what percentage of the average animal's total body weight is constituted by intracellular fluid, ICF? A, 60%, B, 40%, C, 20%, D, 14%. Where am I from? I am from the United States of America, Oklahoma. So, sorry about that. Intracellular fluid is give me one moment. Okay, I'm back. I think it's 40%. No, it's 60%. 60% intracellular, 40% extracellular. Okay, I guess I was wrong. What percentage of the average animal's total body weight is total body weight. Oh man. 40% intracellular by body weight. The 60-40-20 rule states that total fluid is 60%. Total fluid is 60% body weight. Intracellular fluid is 40% of that, and extracellular is 20% of that 60. Okay, something I'm glad I reviewed. Okay, question 6. Which major component is significantly higher in concentration in the plasma compared to the interstitial fluid despite the ECF fluids constantly mixing? A, sodium, B, chloride, C, bicarbonate, and D, proteins. Hey, how's it going? In the plasma compared to the, I think it's D, proteins. Yes, that's the answer. Question 7. What term describes the fraction of blood volume that is composed of red blood cells, RBCs? A, plasma, B, serum, C, buffy coat, or D, hematocrit? I think it's D, because plasma and serum are what separate whenever you centrifuge. Yep, answer is D. Okay, part 3, terminology, osmosis, and tonicity. Question 8. When measuring osmotic concentration in the human body, why are the terms osmolality, osmoles per kilogram of water, and osmolarity, osmoles per liter of solution, often used synonymously? A, because they only apply to the intracellular fluid. B, because the body's solutions are dilute and the differences are small. C, because all ions dissociate completely in the body. And D, because they are only regulated by the kidneys. I think it's B. Yep, that's the answer, because the body's solutions are dilute and the differences are small. Question 9. What drives approximately 80% of the total osmolarity in the extracellular fluid? A, potassium, B, calcium and magnesium, C, sodium and chloride, or D, proteins? 80% of the total osmolarity in the extracellular fluid. Hey, Archie. I think the answer is sodium and chloride. Yes, C. Extracellular is sodium and chloride. Intracellular is potassium. That was question 9. Question 10. What characteristic, hey Garden. Question 10. What characteristic of particles determines the osmotic pressure of a solution? A, the mass of the particles, B, the velocity of the particles, C, the number of particles per unit of fluid, or D, the charge of the particles? The answer is C, I believe. Yes, the number of particles. Scottish Highlands, that's cool. Glad you're watching. It's good to see you. What's it like over there, if you don't mind me asking? Question 11. If a solute has a reflection coefficient of 1, how is that solute best described regarding membrane permeability and osmotic effect? A, completely permeable, no osmotic effect, like urea. B, impermeable, creates osmotic pressure, like serum proteins. It's freezing, because that's way up north, isn't it? Is there snow right now? C, semi-permeable, creates minor osmotic pressure. Hey, Aiden. D, completely impermeable, no osmotic effect. Wow. Well, I do like snow, but I don't know if I'd like to be around it all the time. That's awesome, though. I've never been to Scotland, so it'd be cool to visit there someday. The answer here is B, I believe. Yes. 12. A red blood. Hey, Big Lon. Good to see you again. How you doing, man? Question 12. A red blood cell placed into a solution begins to swell. This solution is described as having what tonicity? A, isotonic, B, hypertonic, C, hypotonic, or D, effective? The answer is C, I believe. Yes, hypotonic. Part 4, fluid interfaces and regulation. Oh, whoops. Went a little too far there. Fluid movement across the cell membrane, ICF, ECF interface, is driven solely by which force? A, hydrostatic pressure, B, oncotic pressure, C, osmotic force, D, capillary pressure. The answer is C, osmotic force. Oncotic pressure, I don't even know what that means. Let me look that up real quick. Oncotic pressure. Nah, I didn't say osmotic. Oh, oncotic pressure, also known as colloid osmotic pressure. So it's a type of osmotic pressure, but it's not general osmotic pressure. Interesting. Okay. Yes, the answer is C. Okay, question 14. Why is the precise regulation of ECF osmolality prioritized over ECF volume regulation? A, ECF volume affects cell volume more immediately than osmolality. B, ECF osmolality directly affects cell volumes and function immediately. C, ECF osmolality changes require ADH, which is easier to control than volume. And D, ECF volume is unregulated in healthy animals. Osmolality. I think the answer is B. Yes, answer is B. ECF osmolality directly affects cell volumes and function immediately. Question 15. Aldosterone or aldosterone, I don't know how you say that, plays a key role in regulating extracellular fluid volume, ECFV, primarily by increasing the reabsorption of which substance in renal principal cells? A, potassium, B, sodium, C, water alone, and D, chloride. Thank you, Garden. Sorry to hear about your husband. I'll try my very best to be a veterinarian. I'm not a veterinarian yet, but I will be in about 3 3/4 years. So thank you. I appreciate that. I wish the best to you as well. Aldosterone. I think it's C, just because of the way it's worded so weird. Nope, it's B. Sodium. Aldosterone increases sodium reabsorption in renal principal cells. It also increases ECFV. Where's my donations button? I don't have one yet because I don't have 500 subscribers yet. I've only got, I think, 174 or so. Sorry. But once I get 500, thank you very much. I've never had anyone say that they've wanted to donate before. That's awesome. That's very kind of you. Thank you very, very much. Anyway, sodium absorption is increased by aldosterone in renal principal cells, and it also increases ECFV because it increases water reabsorption along with sodium, meaning it regulates ECFV, not extracellular sodium concentration. Question 16. A patient suffers severe acute diarrhea leading to isotonic fluid loss. Keyword isotonic. Which compartment's volume changes first, and what determines the subsequent change in ICF volume? A. ICF changes first, and it's determined by ECF NaCl content, sodium chloride. B. ECF changes first, determined by ICF osmolarity. Thank you, Garden. I'm going to keep going. I appreciate the encouragement. Yeah, I'm really enjoying this so far. I'm glad I get to talk to people like you, and it's awesome. Very refreshing. So thank you for your support. B, ECF changes first, and it's determined by ICF osmolarity. C, ECF changes first, determined by ECF osmolarity. D, ICF changes first, determined by ICF NaCl content. So they're suffering from isotonic fluid loss. I believe that the extracellular fluid extracellular fluid would change first. And I think it's determined by the osmolarity of that fluid. Yes, that is the correct answer. ECF changes first, and it's determined by ECF osmolarity. All right, part 5, clinical fluid abnormalities and cell volume regulation. Hey, Aiden. How you doing? Okay, question 17. Hyponatremia is diagnosed when plasma sodium concentration falls below which value in MEq per liter? A, 160, B, 142, C, 120, D, 180. The answer is, thank you, Garden. I appreciate that. I think the answer is B. Hyponatremia. Yes. 142 MEq. Yes, that is the answer. B. Plasma sodium falls below 142. Okay. Question 18. What is the specific cellular adaptive mechanism utilized by brain cells to reduce swelling, edema, in response to gradual hyponatremia? A, regulatory volume increase. B, osmotic diuresis. C, regulatory volume decrease. Or D, vasogenic edema. think it's either A or C. Regulatory volume increase or decrease, I think. I'm just going to guess and say A. Nope, it was C. Regulatory volume decrease when the brain experiences gradual hyponatremia, not hypernatremia. I think if it experiences gradual hypernatremia, it will respond with regulatory volume increase instead of regulatory volume decrease, like in hyponatremia. Okay. Question 19. Which clinical abnormality is associated with a higher case fatality rate in dogs and cats, even though it is found less frequently than its counterpart? A. Hypernatremia. B. Hyponatremia. C. Cytotoxic edema. And D. Third spacing. I think it's either A or B, hyper or hyponatremia. And I would say, I think hypernatremia, because I think it's found less frequently than hyponatremia. Yep, that's the answer. Because I remember reading that, if you eat too much salt, you're just going to get super thirsty and drink a bunch of water anyway. So, okay. Question 20. Which type of brain edema is characterized by the loss of the blood-brain barrier, allowing protein extravasation and water accumulation, often seen following focal inflammation or injury? A. Cytotoxic edema. B. Vasogenic edema. C. RVI. Or D. Third spacing. I know that. Okay, these questions are getting a little weird and kind of easy. Those last two, I don't think have anything to do with this. I would say cytotoxic edema. It's either that or vasogenic edema. The answer is vasogenic edema. Okay. Vasogenic edema is characterized by the loss of the blood-brain barrier, resulting in protein extravasation with water following. Cytotoxic edema is associated with loss of oxygen and accumulation of intracellular sodium. Okay, I didn't know that. 21. Which of the following is not listed as a major endogenous safety factor that normally helps prevent edema? A. Wide range of lymph flow. B. High compliance in the interstitium. C. Low compliance in the interstitium when pressure is negative. And D. Wash down of interstitial fluid protein concentration. A and D are not it. I think it's B. Yep, it's B. Okay, part 6. Blood components. Question 22. What is the difference between plasma and serum? A. Serum contains clotting factors. Plasma does not. B. Plasma contains an anticoagulant and clotting factors. Serum does not contain clotting factors. C. Plasma is the cellular component. Serum is the fluid component. D. Serum is only found in the ECF. Plasma is only found in the ICF. I don't think it's C or D. I think it is A. No, it's B. Plasma contains an anticoagulant. Plasma does contain anticoagulants. Wow. All right. Plasma contains an anticoagulant and clotting factors. Serum does not contain clotting factors. Question 23. What unique structural characteristic of mature canine and feline erythrocytes, RBCs, limits their lifespan? A, the biconcave disc shape. B, the presence of hemoglobin. C, the absence of a nucleus, a nucleus. Or D, the presence of carbonic anhydrase. I think it's either C or D. I'm going to guess D. Nope, it's C. That was my gut choice. The absence of a nucleus leads to their limited lifespan. Question 24. Jaundice, or icterus, in an animal is caused by abnormal hemolysis, leading to the end product accumulation of which substance? A, heme. B, bilirubin. C, thrombopoietin. Thrombopoietin. D, reticulocytes. The answer is B, bilirubin. Part 7, vasculature and smooth muscle. Question 25, sorry, I'm getting my brain's getting fried. Which layer of the classic blood vessel structure is primarily composed of collagen and connective fibers, providing structural support and anchoring the vessel? A, tunica intima. B, tunica media. C, tunica externa or adventitia. And D, the basement membrane. The answer is C, the tunica externa. Yep, C. Because it's on the externa, right? It's on the outside. Question 26. According to Passai's equation, why are arterioles considered the resistance vessels where the greatest pressure drop occurs? A, they are the longest vessels in the vascular tree. B, they have the highest compliance, allowing for volume accommodation. C, small changes in their radius significantly change resistance, which, if you remember, that relationship was inversely proportional to resistance to the fourth power. And D, they act as the Wind-Kessel effect pressure reservoir. The answer is C. The small changes in their radius significantly change resistance. Okay, question 27. What type of capillary features large gaps about 30 to 40 micrometers, I think is what they're trying to say here, and a discontinuous basement membrane facilitating the free transfer of proteins and blood cells? A, continuous. B, fenestrated. D, discontinuous, sinusoidal. Or D, capillary recruitment. Okay, D doesn't make any sense, right? You can't have a capillary recruitment capillary. That doesn't make sense. Okay. Large gaps. I would say it's C, discontinuous. Yep, that's the answer. Question 28. Which type of smooth muscle cell arrangement is characterized by discrete separate fibers that are innervated by a single nerve and rarely possess gap junctions? A, single unit or syncytial. B, tonic unit. C, multi-unit. And D, phasic unit. So only two of these were talked about, single unit and multi-unit. I believe it is discrete separate fibers that are innervated by a single nerve and rarely possess gap junctions. I think it's A, single unit. Nope, it's C, multi-unit. Again, I probably should have gone with my gut. Oh, it's so confusing. So multi-unit ones are innervated by a single nerve. That makes sense, actually, if you think about it. The phrenic nerve going to the diaphragm, for example. Question 29. The contraction of smooth muscle is unique compared to skeletal muscle because of the presence of the latch mechanism. What does this mechanism allow SMCs to achieve? SMC meaning smooth muscle contractions. A, rapid short bursts of contraction, phasic. B, very low energy consumption needed to hold full contraction. C, a response exclusively to nervous system input. Or D, contraction independent of intracellular calcium. I think it's B. Very low, yep, it's B. Very low energy consumption needed to hold full contraction. Good to know. Part 8. Heart anatomy, excitation, and cardiac cycle. Question 30. Which side of the mammalian heart is described as a high-pressure, long-distance circuit that pumps blood systemically via the aorta? A, right atrium. B, right ventricle. C, left side. D, pulmonary circulation. C and D are completely throwaway answers. Okay, so I got an AI to like compile my notes into this study guide, and these questions are not, I mean, some of them are difficult. I just don't know the answer, but some of them like this are easy. High pressure, long distance circuit that pumps blood systemically via the aorta. Okay. So it's, okay, wait. C and D are not throwaway answers, actually, I don't think. Because the right atrium and the right ventricle don't pump blood via the aorta. They pump blood via the pulmonary trunk to the lungs. And so I think it's C, actually. Left side, which isn't a very good choice, but yep, that's the answer. C. Whatever. Question 31. Which heart valve features 3 leaflets or cusps and is connected to papillary muscles via chordae tendineae? Well, that first descriptor gave it away. It's, well, hold on, let me read the options first. Mitral valve, aortic valve, pulmonary valve, and tricuspid valve. A, B, C, D, respectively. The answer is D, tricuspid, because it said 3 leaflets or cusps. Yep. Question 32. In the 3-chambered heart of most amphibians/reptiles, what unique feature helps minimize the mixing of oxygenated and deoxygenated blood within the single ventricle? A, a complete septum dividing the ventricle. B, the use of accessory hearts. C, extensive trabeculations in small internal chambers. Or D, the Purkinje system. D is completely unrelated. The answer is C here. Extensive trabeculations in small internal chambers. Question 33. What is the primary function of the atrioventricular node within the cardiac electrical conduction system? A, generating the fastest electrical impulses to set the heart rate. B, rapidly conducting impulses to the ventricular muscle. C, deliberately slowing conduction to allow ventricles time to fill. Or D, controlling the heart's contractility via neural innervation. I think it's C. Yes, the answer is C. Deliberately slowing, excuse me, deliberately slowing conduction to allow ventricles time to fill. Question 34. Which phase of the cardiac myocyte action potential is characterized by the closure of fast sodium channels, the continued opening of L-type calcium channels, and initial potassium efflux? A, phase 0, depolarization. B, phase 1, initial repolarization. C, phase 2, plateau. And D, phase 3, repolarization. Well, phase 1 doesn't exist, so B's not the answer. Now I just got to remember which one's which, because phase 0, 2, and 3 did exist. I think it's either A or C. I think I'm gonna guess C. Nope. The answer was B, phase 1. What? That's a bunch of hooey. I don't remember seeing that. Whatever. Because phase 1, initial repolarization, occurs when fast sodium channels close, calcium channels continue to open, and potassium leaves the cell. Okay. Question 35. In cardiac contraction, calcium ions released from the sarcoplasmic reticulum, SR, so that's what SR means, must bind to which component of the troponin complex to initiate contraction? A, troponin 1, B, troponin T, C, troponin C, D, tropomyosin. I think it's A, because that's the only one I remember talking about. No, it's troponin C, which is option C. Troponin C has a high affinity for calcium. Makes sense. Troponin C could mean troponin calcium. The binding of calcium to troponin C induces a conformational change that pulls tropomyosin away from the active sites on actin, allowing contraction to occur. Question 36. During the cardiac cycle, which physiological event is S1, or the first heart sound, lub, associated with? A, closure of the semilunar valves at the end of systole. B, vibration of the ventricles during rapid filling. C, closure of the AV valves at the onset of systole. Or D, atrial depolarization. It is not B and it is not D. I think it's C, closure of the AV valves at the onset of systole. Yes, that is the answer. Question 37. What term describes the pressure/tension on the muscle fibers before the heart begins contracting, typically measured as the end diastolic pressure? A, afterload. A, afterload. B, inotropy. C, chronotropy. Or D, preload. It's D. The middle two, B and C, I haven't even heard of. And A is after. The question specifically asked which one does it before. So, yep, D is the answer. Part 9, electrocardiogram and arrhythmias. Question 38. On an ECG trace, what electrical event is represented by the P wave? Ooh, I think it is... Okay, A, ventricular repolarization. B, atrial repolarization. C, atrial depolarization. And D, ventricular contraction. I think it's C. Yes, it is. Which makes sense because the blood's leaving the atrium, the right atrium, going into the ventricle. That kind of makes sense. First, in the heartbeat, the P wave, right? You got the little bump, and then you have the QRS complex, and then you have the T wave afterward. Yeah. Okay. Question 39. Assuming an ECG machine is running at the typical standard calibration of 25 millimeters per second, what time duration does one large horizontal square, 5 millimeters, represent? A, 1 second, B, 0.04 seconds, C, 0.2 seconds, or D, 0.8 seconds? It's C, 0.2. Question 40. Which specific characteristic in an ECG trace is the hallmark waveform finding for atrial fibrillation? A prolonged PR interval. B, tachycardia, which is a fast heart rate. C, absence of P waves and an irregular rhythm. That's the answer, I can just tell you. And D, tall spiked T waves. The answer is C, absence of P waves and an irregular rhythm. Question 41. In the context of AV blocks, what is the description for a third-degree heart block? A, intermittent conduction with dropped QRS complexes. B, prolonged conduction with an increased PR interval. C, complete heart block where atrial and ventricular rhythms are independent. Or D, three or more sequential ventricular premature contractions. It's C. A third-degree heart block is a complete heart block where atrial and ventricular rhythms are independent. All right, and that's it. That was all for Phys and Histo. So, thank you all for watching. Sorry that took so long. That was literally like, well, let's count it here. That was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 days worth of physiology and histology, all cramped into one. So, yeah. Sorry about that taking so long. But it's over with. Thank goodness. And so that concludes this stream. Thank you for watching. Thank you for tuning in, if you did. And appreciate you all. And I'll see you in the next one. See you later.